In today's video, we are going to build this exciting project. Is the healthcare chatbot using Llama 2, Langchain, and Streamlit, and it's going to have a memory. That means that it's going to have a historical conversation, and we are going to do that on the CPU machine, so you don't have to worry about a GPU. All right. Okay. So this is how it looks like. It's a data that was collected from healthcare. It is a mental health and mental illnesses data from the ResearchGate that I got from online, downloaded that. It has 13 pages. Okay. So we are going to build a chatbot around this data by the help of the LLM that is going to be the Llama model. Okay. So as you can see, it has some data defining mental health and mental illnesses, definitions. Okay. Yeah. So I'm going to walk you through that step by step. Let me show you briefly how this works. So I'm going to say you ask a question about mental health related question. I'm going to say how can I improve my mental health? Okay, I'm going to hit send because it's running on CPU. It's going to take some time. Okay. All right. So as you can see, we have an answer, and it's saying that there are many ways to improve your mental health, including seeking professional help from a therapist or counselor, practicing self-care activities such as exercises. So you can see that this is giving us an incredible answer, and also it's also taking records of the history. All right. So this is an awesome project, and we are going to build it step by step. Okay. All right. So first things first, we are going to be using the Llama model, the GGML, that is the quantized version. It is nothing but the memory is being reduced. So we are going to be using, you can choose to, choose any model that you want to use here, depending on your size of memory. Okay, so in this case, we are going to use the Q4, that is the quantized version. Okay, so you can go here and click on download. I have downloaded that already. So thanks to the block for putting this together. Okay, all right. So once you have that, we will go to Hugging Face and get the API token access. So when you go to your settings here, settings, and you come to access tokens, you can get your API access key right here. So you click on the copy, right? Right, and we are also going to be using the sentence transformers, all right, for the embedding. Okay, that is from the Hugging Face models. Okay, so that is pretty good at clustering or semantic searches. So we're going to be using that for creating the embeddings. All right. Okay, so let's get into some coding stuff. But before that, I want to take you through the architecture. Okay, so this is our document. So this is going to be the healthcare PDF. So it's going to be extracted here, and it's going to be split into chunks. So when it's done, we will, after splitting them into chunks, we're going to be, so you can see chunk one, chunk two, we are going to create an embeddings. So there's nothing but the representation of these text into numbers. By that way, we are going to create the knowledge base from there. So as it is being embedded here, so at this point, we are going to use the Hugging Face embedding. So that is the sentence transformers to do our embeddings. Okay. And it creates an understanding here. So is that the semantic searches, and it's being stored in the knowledge base. Okay. So at this point, we are going to use the phase. So the phase is nothing but, let's see here. It's nothing but Facebook AI similarity search, and it's a library for efficient similarity search and clustering of dense vectors. So we're going to be using that. So you can use the option, other options like the Chroma DB. So we are going to use the Faiss for today. Okay. And at the knowledge base, so when a user asks the question is also embedded. It goes through embedding. Is so when it's embedded here, we create a semantic change. So embedding, just like here, so it changes to numbers and it gets into a semantic search and it's stored in the knowledge base here. So it creates an understanding of the question from the user and the knowledge base. All right. So it's trying to find a similarity in there. And when it gets the answer, there will be the ranking and it gets passes through the LLMs and the user gets the answers. Okay. It's pretty easy. All right. So these steps are called the injection phase. Right. So let's get into it. So we are going to get into our coding. We're going to, so I'll be putting, attaching this to the GitHub so you can pull that. You can clone it so you can start installing it and working on it. Okay. So first things first, I've already uploaded my data. Okay, it's running. All right. So this is the mental health data, and I've created an environment. Okay. So let me show you something real quick. If you want to start a new project, you, as you can see right here, I have my environment created. But you can do that by saying Python -env, then you say env, you hit enter. You are going to get the environment installed here. And we are going to create an .env. So that is where we are going to store our secret API keys. As you can see, this is my Hugging Face API token that I got from the Hugging Face, settings. Okay, and so the next thing, so this is the model that I downloaded. We are using the quantized version, right? So we have that installed here. We have that here, and the requirements. So these are the packages that we are going to install that's going to help us with the project. Okay, so you can see all this in here. I'll be attaching them in my GitHub so you can install them. Okay, all right. So we're going to be importing these packages. We are going to import Streamlit as ST for our API. I'm sorry for the app, Streamlit chat. All right. So we are going to create our messages boxes with the Streamlit chat. We are also going to need a conversational retrieval chain to create a conversational memory. Okay. And we are also going to need the PyPy PDF and the directory loader for the PDF loading and accessing them, Hugging Face for embedding C transformers to load the model from Hugging Face. So we're going to need the C transformers to transform that. And we are going to use the recursive character docs split to split the text phase to store our embeddings and the conversational buffer memory. So this is what is going to be used to create a memory. All right. So the next thing we are going to do is we are going to create a load. So we are going to say load PDF files. Okay. So let's say loader is equal to direct directory loader, and we're going to say, so we're going to target this folder, load the document. Okay. And let's say, guys, we're going to be doing a lot of coding more than the talking, so bear with me. Okay. So globe is equal to So this nothing but just to make sure we grab the whole PDF in the folder and loader CLS will be equal to Py PDF loader. Okay. So this ensures that we get the documents from the directory. I'm going to name it document is equal to loader dot load. Okay, guys. So before I forget, if we have to store the requirements, right? So within there, fastest way is to do a pip install .r requirements, right? And then txt. Okay, so that way everything is installed. I have that installed already. So yeah, just to let you know. Okay, so after loading that, next thing is to split. So when we are done with the document, we're going to split. So split text into chunks. So we're going to split the text into chunks. So let's say text splitter is equal to recursive character splitter. I'm going to say chunks. So chunk size will be mostly dependent on your data. Okay, I'm going to choose 500. And the chunk overlap is going to be 50. You can choose whatever size you want depending on your use cases and the text size, text chunk. Right. So this is the chunks. Let's go to the text. So we are splitting it now. It's equal to split documents. All right. Okay. So now let me show you here. We got the document, we extracted it, and we split it. And here we are here now into chunks. All right, so let's move on, create our embeddings. Say create embeddings. So embeddings, nothing but presentation of the text into numbers so the machine can make meanings from it. Okay, so we're going to use the Hugging Face embeddings. So that is where we are going to use the sentence transformers from Hugging Face to create our embeddings. So let me just go there and copy that, right? Copy that and paste it in here. Perfect. Let me do a comma. I'm going to say running everything on a GPU. It's probably going to take about the whole thing is probably going to take about 9 to 10 gig, something. Yeah. Size, CPU. Okay. Right. So the next thing is create a vector store. Create a vector store. You say vector store is equal to base dot from document text. So from the text chunks, it's creating the create embeddings for each of them and installs them here in a vector store. Okay. And the next thing is to create our LLM. Okay. I'm going to name it LLM is equal to C transformers. I'm going to load the model. The model is equal to LLM. Right. I think I should just go here and copy that. Oops. Go here. Go here. Say rename. Let me just copy this. Come here. I want to paste everything here. Right. And I'm going to say bin. I'm going to say model type is equal to Llama, and the config. So we're going to choose the max size token. So the max new tokens is equal to 128. And the temperature. So it's going to take the randomness of the outcome, right? So I'm going to do that 0. So guys, you can choose the temperature that you want here, depending on your use cases. Okay, right. Let's see. Okay, take this one out. Right, perfect. So the next thing is create a memory. So I'm going to say memory is equal to the conversation buffer memory. Okay, so we are creating that memory key. Let's call it the chat. It's going to store the chat history in our memory. And say return messages. So we wanted to return the messages. We're going to set that to true, okay? Because we wanted to turn our messages, our historical messages, okay? Is to create a chain for retrieval. So create a chain, okay? Dots from LLM, LLM, okay? LLM. I'm gonna say chain type. We call it stuff. Okay. So there are other options that you can use here with the chain type. Using this for now. So retriever is equal to vector store. So I'm passing my vector store into the chain, okay? And in that is where I'm going to search for the answers. So I'm going to do a search quad equal to K2. I'm going to, will be, so I will be retrieving the top two answers, okay? So you can choose whatever sizes that you want. Okay, top two answers, and then memory is equal to. So we are passing our memory here. So we pass our memory here. Memory, pass it inside the chain. Right. So the next thing is to create the Streamlit application. Say title. I'm gonna name it Health Care Chatbot. Right. And probably an emoji in there. Let me see. Okay, let me copy this guy. Okay. And paste this guy here. Right. So let me save it and let's run it and see. 3 minutes. Run. Apply. See. Looks like there's an arrow. Chunk size like 16. Let's see. Okay. Okay. Think I had an X here. So let's save it and run it again. Not this one. Let's run it again. Okay. Let's see. Let's run it again. Yep. So that's the initial output. So let's move on to the next one. So we want to create a conversation. So we say conversation query, conversation chat. I'm going to pass in the query, right? And I'm going to print the results. Say results. I'm going to pass in the chain and the question. And say put that in the quote query. So the query is whatever the user is going to put in. So it's going to be the question. We'll pass in the chat history. That is going to be the section history. Okay. History. Okay. All right. So let's move on to the section state. the section state, and we're going to pass in the history. Say history. Now we append the query and the results. So this is nothing but just creating a conversational chat where we are going to pass in the query, the chat history, and we want to retrieve the results. Okay. And it's going to be the query and the answer. So we want to put all that, append that to the history, and now we're going to return the results. Pull this down. The results as the answer. Right. The next thing is create another function to initialize the section. We want to initialize the section state. So we have 3 sections that we want to initialize. We want to initialize the history. So the conversation chain is going to involve the history and the generated. That is the answer we are getting, and also the past. Okay, so if history is not in the state section, should return an empty list. So if there is no history, nothing should be returned. Right? History. Okay. And if the generated in section, right? That is on the section. We are going to say that section state is generated will be equal to, say, something like hello. Okay. Ask me anything. Ask me anything. Okay. Right. The next one is the other condition is if not in st section state, I'm going to say for the past be equal to compassing something like hey, and create another function to display the chat history. Okay. Chat history. Put in my chat history. I'm going to say create a reply container just to shape the output. Should be in a container. Okay, so we want to say streamlit.container. Guys, I'm going to put a description to the Streamlit documentation. It's quite an interesting one, so you can also go through that. So we say container is equal to st container. So we pass in the container, initialize initialize the container. So container is equal to st instantiates that. And now, so we're going to apply the container. So with container, now let's create something. And with, we want to create a form for the user to input a query. So I'm going to say key is equal to my form. Okay. I'm going to say clear on submit is equal to true. So anytime the user inputs a question, you should clear the this in the box in the form to start a new input. Right. So the user input is equal to create a text box now where the user inputs query, the question. Right. So this is nothing but the form, the text input. So the user will input a question. Okay. I'm going to say placeholder, placeholder. We want to get this in the holder so that the user will know what to type about. Okay. So something like mental health. And we are going to do the key as input. Okay. The user should input the question. Now the user should make a submit. So we want to say build a submit button. It's equal to form. So Streamlit way of submitting st.form submit button. Okay, so when you hit on that, it's going to send that in order to get the answer. Okay. All right. So far, so good. So the next one is to create a submit. So if the submit in the user input, so if we have this button in the user input and that is ready, we want to create an output to be equal to now we are calling our conversation chat. So we are calling this function right here that contains the query. So we are passing it here in the user input, right? So that when the user inputs the question, we are going to get the answer, okay? And within that submit button and the user button, we want to also get the section state. We want to get the section state of the past conversation from the user side. Okay? So that when the user inputs any question, we get the previous input is the past state. We also want to get the generated one. And we're going to say append output. Okay? So we're going to append this user output and the user input and the output into the past and the generated. All right. So the next thing to do now is, so if another condition to say the generated output now we are handling the output. We want to create a container for that. Reply container. So for I in, we're going to iterate through the length of the section for the generated. So we want to create a message. So we are using the Streamlit over here. We are using the Streamlit chat message to get the message that was generated. And we want to put that in, want to get that from the past and the generated. Okay. So section state of the past. Right. So I'm going to walk you through that once again so you get a clear understanding of that. Okay. All right. And is user true? So the user is true. I'm going to say of the, so for I in range, we want to get the iteration of the conversations for the user and the generated. So key string, key is equal to string of I, say the user. Let's create an avatar style. Okay, I'm going to do something like a thumbs. So when you click in here, you can see any of them. So you can select whatever you want to do, put there as a thumb. So I'm going to just choose thumbs. Okay. Right. I want to get the message for the generated. So I want to say, I think I can just copy this and change it. Copy that, paste it. But I want to change this one to generated. Okay. All right. So now what I want to do now is we want to call the function. So initialize section state. So we want to initialize the section state. And we want to display, so display chat history. Okay. So display chat history. Right. I think this coding is done. So what we've done is we've imported the packages for the to run the application. So Streamlit chat, we import the message to create the Streamlit conversation, the conversational retrieval chain to create the memory for conversations to store the historical, and we import the py loader to and the directory loader to get the PDF documents loaded, Hanging Face to create embeddings, C transformer to load the models. From Hanging Face, there's the Llama2 model, and the recursive character splitter to also create the text into chunks, the Faiss to store to do a vector store, to store the embeddings, conversational buffer memory to also implement the memory as well. So we loaded the PDF documents using this code. All right, and we store them into documents and we do a split text into chunks. So we did a chunk size. You can vary this depending on your use cases. So we create a text chunk and split them and store them from here. Documents. So we call them and then we store them into a text chunk. And now we create embeddings from the Hanging Face model. Right. So we created embeddings and we store that locally on the CPU. Okay, so using the sentence transformers and also vector store. So we use the Faiss, right? That's the Facebook similarity search, and we for each of the text and embeddings, the text chunks embeddings, we store them in a vector store, create the LLMs using the Llama 2 model, right? And the token, so you can vary these token sizes and the temperature as well. We start with a memory using the conversational buffer memory, okay? And we call the chat history. Return messages true. We want to return the history, and we create a chain, okay? And for that, so we pass in the LLM that we created here. We say LLM is equal to LLM. That's a chain, and the chain stuff type stuff. You can vary that. Also, we have other ways you can also put that in the retrieval vector store. And the k is equal to 2. We want the top two ranked outcomes, and the memory is equal to memory. We are passing in the memory here. Okay. So we create the Streamlit application. We create a conversation chat. We pass in the query, and we want the results to be using the chain. So we want to get the question so that when the user input a question, and chat history, we want to get the chat history, and also so the chat history is equal to the section of the history. I think this is going to be state. Okay, I think I have this state. Yeah, I think this one is going to be state, section state. All right, and so we get the history, and we're going to append the answers to the history, and we want to also only get the answer, right? And we initialize the section stage for so we have history generated in the past, right? So if none of the history not in the section state, we get an empty list. If it is not in the generated, it's not the section state that the answer that was generated. If it's not the section state, we should say hello, ask me anything. And if the past is not in the section state, we should say hey, something like that. So you can put whatever you want to put there. So def, we create a display chat history. For that, we create a container that is going to hold the chat history. All right, so this is how we want it to be displayed. We create a container called the st.container. Okay, we instantiate it, so we have a reply container and a container. All right, so with the container, we pass in the form for the user to input a form. So the user, so if the upon submit, okay, clear on submit. So if user input in the question, it should clear for the next question. So the user input, we are passing the question and what we want to ask in there. All right. So you can say ask about your mental health, whatever you want to put there. All right. So if submit button, if there is submit and the user button, we want to get the conversation chat and the user input. Okay. So this time we are passing the conversation chat for the query in here for the user to input a question. And we also want to get so upon submit and user input, when that is clicked, we want to get the past, the generated output. So we want to get these conversations. So if section or state is generated, if that is generated for the answers, so with reply container, it's going to iterate through the generated and it's going to give us the past and the generated. All right, and it's going to come out with some emojis as well. So we are now going to call these initialize section state and display state for the application to run. Pretty good. All right, so let's save it and run it. Okay. I think I'm just going to refresh it. Let's give it a few. So we are getting an error on line 72. Let's see. This is the 8. See what the error is. Okay, so let me change this to an emoji. All right. Save it and run. Right, so there's an error here. Let's correct that. User. Right, we don't have to put in the user there, okay? Because we already have it here, okay? So generated, it's not from the user, okay? All right, so let's save it and let's run it. Let's run by. All right, so let's ask a question. How can I improve my mental health? Yeah, so as you can see, we have our answer here. Yeah, so this is pretty much how it works. Okay, so you can see it's giving us an answer. There are many ways to improve your mental health, including seeking professional help from therapists and all that. Yeah, awesome. So, yeah, I hope you like this video. Don't forget to subscribe and share. So, I will attach the link to the GitHub so you can get the code. All right. Thank you for watching and see you in the next one.